Hello chemistry students, we're going to be talking about ionic compounds today. So one thing you do need out is you need out your notes, your notebook, wherever you write important information about chemistry. You're also going to need out your periodic table, and we're going to get rolling here. So today's topic is about ionic compounds, and we're going to talk about what an ionic compound is. We're going to talk about how you identify an ionic compound, and then we're going to talk about how you write formulas for ionic compounds. So that's our goal today. An ionic compound could be defined as it's a compound made of a metal plus a nonmetal, or nonmetals. So if we just a quick little reminder, if I'm going to draw a little rough periodic table here. If this is our periodic table, and then there's a little that stair-step line right there. Our metals are located over here, including those transition metals, and of course our nonmetals are located over here. And so anytime we put these type of elements together, if it's got a metal in it and a nonmetal, or nonmetals, more than one, there's a good chance we have an ionic compound going on. Let's talk about what holds these guys together really quickly here. So these guys have what's called an ionic bond. That's what holds metals and nonmetals together. And it's due to a few things. One, it's due to a transfer of electrons. When we transfer electrons, either lose or gain, we form positive or negative charges. And then there is opposite charges, and opposite charges are attracted to each other. Positives are attracted to negatives, so they come together to form this compound. And of course, we know that cations are positive ions. These are our metal ions. And anions are our negative ions. These are our nonmetals. So this is a lot of the stuff that we've been talking about for the past few days in cations and anions and things like that. So again, that's an ionic compound, metals plus nonmetals. They contain ionic bonds, transfer of electrons, opposite charges, cations and anions coming together. I want to give you some examples now of some ionic compounds. So I'm going to scroll down a little bit here. And if we're going too fast, you can ask to slow this down or pause this if you need to get caught up. So here's three different examples of ionic compounds. The first one here, we have NaCl. This is NaCl right here. And we can see that in this molecule we have one sodium atom and we have one chlorine atom. Together, and they're just squished right up together, so we call that a compound. This would be an ionic compound because, again, that metal is listed first. Right here we've got magnesium. We've got just one magnesium here. And then we've got some chlorine here, and it looks like we have two chlorines per one magnesium in this compound. And we'll talk about why that occurs later. Again, it has a metal in the beginning of it, and it's got a nonmetal, so this is probably an ionic compound, and it is. And this last one here, we have calcium, and it looks like we have three calciums. That three behind the calcium tells us that there's three of those in this compound. And then we also have nitrogen there, and that 2 tells us that there's 2 nitrogens in that. So again, there's our metal listed first, there's 3 of them, and this is also an ionic compound. So those are good examples of ionic compounds. An example of somebody who is not an ionic compound would be somebody like, let's say, PCl3. Phosphorus is a nonmetal, and chlorine is a nonmetal. So this is a different type of compound we'll be talking about later, but that's a non-example of an ionic compound. Go ahead and erase that. Okay. Now, our goal for today, a real big goal, is not only to be able to identify ionic compounds, but to be able to write the formulas for ionic compounds as well. And there's 3 rules when we write formulas for ionic compounds. There's actually a couple more rules that we'll talk about later, but here's the first rule, and we want to make sure we jot this stuff down into our notes so we can always refer back to it. Rule number 1 is we're going to want to write the metals first. So metals always come first in an ionic compound. They are on the left side of the periodic table, so write them on the left side of the ionic compound, you'll always be okay. We want to figure out what the charges are, and I've already told you how to find charges on your periodic table, and I'll just review it super quickly right here. Here's a periodic table. Everybody, and over here we've got our alkali metals. Everybody in this group is going to form a 1+ charge. alkaline earth, everybody here is going to form a 2 plus charge. We're just going to ignore for the moment the transition metals. We'll get to those guys later. 3 plus charge over here in that boron and aluminum group. Carbon doesn't form a charge over here. That nitrogen group is a 3 minus. Oxygen group is a 2 minus. That fluorine group is a 1 minus, those halogens. And then, of course, over at the end there we have the noble gases, which we're not going to worry about because they don't form ionic compounds. They don't. Now, we're going to talk about doing something called crisscrossing charges to make a neutral compound. And the neutral part of this compound is really important. We're also going to reduce if necessary, and I'll talk about that in an example down here below. So those are our 3 rules. Make sure you get those 3 rules into your notes. And I'm going to give you just a brief moment here to get caught up on writing if you need to get caught up on writing. Okay, so if you do need more time, 1, you can always rewatch this video. 2, you can always pause it. I'm scrolling down a little bit here now. Now what we're going to do is we're going to learn how to write the formulas for each of the following compounds. And I've given you names here, and then you're going to write the formula. So the example says write the formula for both of them. So very first one here, we have potassium iodide that we're going to learn how to write this formula for. So the first thing we need to do, and I'm going to write these out in a long way, which I recommend that you do until you get really good at it, and then you can sort of shorten it up. So this is the long way to do it, and this is the way I do it for the long way. So first off, I'm going to say, okay, I have potassium, and I want to look up on the periodic table potassium, and some of us already know that this is the symbol for potassium is K. And then I'm going to look up the formula, or the symbol for iodide, and that is the name of iodine when it forms an ion. So it's K. It's an I. Okay, I'm going to put a plus in between these two. Now, the next thing I'm going to do is I'm going to look up the charges for each one of these. So potassium is in group 1A. So everybody in group 1A, that alkali metal group, is going to form a 1 plus charge. And iodide is going to form a 1 minus charge, as does everybody who is in the halogens group, this group 7A. Now, what we're going to do now is we're going to put these two together. Because they have opposite charges, they're attracted to each other, and we want to end up with a neutral compound, and that's our goal. And we're going to. So here's what we do. Here's the trick to this. I'm going to do what's called the crisscross method. So the crisscross method takes the charge and the number of the charge, and it crisscrosses it. I'm going to take this number and I'm going to bring it down behind the iodine, and I'm going to take this number and bring it down behind the potassium, just like that. And so what that's going to leave me over here is going to leave me K1 and I1. And I'm not worried about the charges. I've gotten rid of that. And notice that there's no charges written up here. That's what we want. We don't want to have charges written up there anymore. Now, because I have the same number, 1 and 1, I don't really need to write 1 and 1. It's assumed that if I write K, there's at least one of them, and I, there's at least one of them. So if I have 1s, I can erase 1s off. There's no need to really even write them. So there's our new formula, Ki, and we're good. Okay? So let's scroll down here a little bit more, and we're going to look at magnesium oxide as our next one. We're going to do the same thing. We're going to start off. We're going to write the formula for magnesium, which is Mg. We're going to write oxide, which is our ion name for oxygen, just like that. Now what we're going to do is we're going to look up the charges of each one of them. So magnesium is in the alkaline metal earths group, so we're going to write 2 plus charge. And oxygen is in that group 6A, and we're going to write a 2 minus charge, just like that. What we're going to do now is, like I said before, we're going to crisscross these charges. So we're going to take this number 2, and we're going to bring it down right there. We're going to take this number 2, and we're going to bring it down right there. And so let's come over here and go Mg2O2, just like that. Now we're really close on this, but there's one other thing we can apply here. Because we have the same number, or we have a number that can be reduced, this number can be divided by 2 and 2. So what we're going to do is we're going to divide both of these by 2, and we're going to make this MgO. If we can reduce, we go ahead and reduce in ionic compounds. And really what that means is it really only takes one magnesium and one oxygen to make a neutral compound because they both have the same charge. They're both a 2 plus and a 2 minus. When they have different charges, that's where things get interesting, and we'll talk about that next. So our final answer here is MgO. If you write Mg2O2 on a test, you'd get it wrong because you need to reduce when you have the chance. So anytime you have the chance, reduce if possible. The same goes if you had 3 and 3, you would reduce that down to 1. If you had 4 and 2, you would divide both of them by 2, and then you'd have 2 and 1. We'll talk more about that later. Let's go on to our last one, and now we have calcium bromide, and there's going to be some practice problems for you to do. Calcium bromide. Calcium has the calcium atom, and we're going to add it to bromide, which is the name for the bromine atom when it's an ion. We're going to look up our charges now, and so calcium is in column 2A, so it's got a 2 plus, and bromine is in column 7A, it's got a 1 minus. Okay, so we have different numbers here. What we're going to do again, we crisscross the charges, we bring that down, and we bring that down to make a neutral compound. And so what are we going to get? So we're going to get Ca, and we brought that 1 down from the bromine right here, and we don't need to write it. When we bring 1s down, we don't write it. And then we have the Br, and we're going to bring that guy down, and we're going to put a 2 right there. So really what this is telling us, and we cannot reduce this anymore, what this is telling us is it takes 2 bromines, because they have 1 minus charge, to neutralize out 1 calcium with a 2 plus charge. So we would have, in reality, a calcium plus a bromine with a 1 minus plus a bromine with a 1 minus. And that's what gives us that answer up there. So we're looking to get a neutral charge. So this is our final answer. It cannot be reduced down. Those numbers at the bottom have to be whole numbers. Okay, so there will be, hopefully you got all those notes down. There will be a worksheet that goes along with this. Have a nice day.